Section 2.4, Truth Tables, Conditional and Biconditional Statements, Video 4. In this video, we will cover the following objective: determine the truth value for a specific case. Example 7. Part A, create a truth table for the statement: if we don't invest in renewable energy, then we put the security of our energy supply at risk. Part B, using the truth table created in Part A, determine the overall truth value of the statement in the case that we don't invest in renewable energy and we don't put the security of our energy supply at risk. Let's start with Part A. So we're going to create a truth table for this statement. Notice that it is a conditional statement. It is an if-then statement. I am going to so we need to make letters or choose letters to stand for simple statements within this statement. I am going to let P stand for we invest in renewable energy. Now notice that P could also represent we don't invest in renewable energy. There is more than one correct way to set this up. I'm going to let Q stand for we put the security of our energy supply at risk. So now, using the P and the Q that I chose, we can put this overall statement, or we could write this statement in symbolic form. So if we don't invest in renewable energy, so in other words, if the negation of P, then we put the security of our energy supply at risk, which is Q. So we have if the negation of P, then Q. Again, there's more than one right way to set this up. P could have stood for we don't invest, and in that case, we would have started with just P here. In the end, our final results will be the same. Okay, so now I'm going to make a truth table for this. So we have P, we have Q. We're going to need the negation of P, and then we can create a final column: if negation of P, then Q. So for the P column, we're going to have true, true, false, false. In the Q column, true, false, true, false. We do this the same way every time. The negation of P takes on opposite truth values as the P column. Lastly, we have if the negation of P, then Q. Here, the antecedent is true and the consequent is false. The conditional statement is false in that case. That's the only case where that happens. And so this statement is true in all other places. All right, so now using the truth table in Part B, we want to determine the overall truth value of the statement in the case that we don't invest in renewable energy. Now remember, P stood for we invest in renewable energy. But now we're saying that we don't. So we're saying that P is false in this case. And then we don't put the security of our energy supply at risk. Now remember, Q stood for we put the security of our energy supply at risk. So now we're saying that Q is false as well. So we are not investing in renewable energy, and we are not putting the security of our energy supply at risk. P and Q are both false in this specific case. So what I want to do is consult the truth table, and I'll look for the row where P and Q are both false. And then I want to look at the overall truth value. So the overall truth value of our statement: if we don't invest in renewable energy, then we put the security of our energy supply at risk, is false in this specific case. Example 8. We're going to create a truth table for the statement, the festival is not canceled if it doesn't rain, and they will use vacation time if and only if the festival is not canceled. And then in part B, we're going to use the truth table to determine the overall truth value of the statement in the case that the festival is not canceled, it rains, and they use vacation time. Okay, so again, we need letters to represent simple statements. I'm going to let P stand for the festival is canceled. Now again, if we wanted to, P could represent the festival is not canceled. And maybe I'll do that in this case just to show a different way. So that's what I'm going to let P represent. I'm going to let Q stand for it doesn't rain. Although Q could stand for it rains. Again, just a choice that we're making. And I'm going to let R stand for they use vacation time. So when I normally do this, I choose P, Q, and R so that they don't involve the word not. So I normally would have allowed P to stand for the festival is canceled, and Q stands for it rains. But in this example, I just want to show a different way. In the end, we're going to come up with the same conclusion. All right, so now the statement, the festival is not canceled if it doesn't rain. First of all, notice how we can rearrange this. We can write if it doesn't rain, then the festival is not canceled. So this first part of this statement can be rewritten like that. So notice how that first part is an if-then statement. So if it doesn't rain, so that would be if Q, because that's what Q stands for, it doesn't rain. So if it doesn't rain, so if Q, then the festival is not canceled, which I have P standing for that. Okay, comma, that tells me that those items are grouped together, or those simple statements are grouped together. Then we have and they will use vacation time, which is R, if and only if the festival is not canceled, which is P. So the second statement here, I have represented right there. All right, so now let's make a truth table for this. So we have P, a column for P, a column for Q, a column for R. We're going to do this the same way every time. Then I'm going to need columns for the items in parentheses, which would be if Q, then P, and R if and only if P. And then lastly, I'll make a column for the entire statement. All right, the P column, we're going to label this the same way every time. We've already talked about this previously. If we have 3 simple statements, how we would set this up. All right, so first we have if Q, then P. So if then, we're looking for the antecedent to be true and the consequent to be false. It happens right there. So that's false overall. Happens again right there. So that's false overall. Be careful of the order. That's why I like to write if above the antecedent column and Q and then above the consequent column. All right, then we have R if and only if P. So between these, we have an if and only if. Recall that that comes out true when both parts have the same truth value. So that happens here, 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 and here. Comes out false if the truth values of the two parts that we're comparing are different. All right, now we can look at the whole statement, which is an and statement overall. So a conjunction. If both parts are true, like here and here and here, then the statement is true overall. If at least one part is false, then the statement is false. All right, so now we have the truth table. Now let's look at part B. So we want to look at the truth value of this statement in this specific case. The festival is not canceled. P stands for the festival is not canceled. So that's happening. So that's true. It rains. Q stands for it doesn't rain. Now I'm saying it does rain. So in this case, Q is false. They use vacation time. R stands for they use vacation time. So R is true. So we're looking at the specific case where P is true, the festival is not canceled. Q is false, it rains, as opposed to it doesn't. And R is true, they use vacation time. So I need to consult the column or the row of the table where P is true, Q is false, and R is true. Notice that that is this third row right here. And so overall, we see that the statement is true in that case. So the statement presented in part A is true overall in this specific case. Now notice that we didn't really need to make the entire table. Now we did because part A asked us to, but if our aim was to just find the overall truth value of the statement in this specific case, we really only needed to make that row of the truth table in order to get the information that we wanted. So that brings us to how determining the truth value of a specific case without a truth table. So in other words, we don't have to go through all the work to find the truth value of a specific case. Example 9, determine the truth value of the statement. He is able to get someone to cover his shift and goes on the trip, or he books a later flight and goes on the trip. In the case that he is not able to get someone to cover his shift, he does not book a later flight, and he goes on the trip. All right, so I'm going to let P stand for he gets someone to cover his shift. I'm going to let Q stand for he goes on the trip. Now again, you could arrange this differently if you wanted to. I'm going to let R stand for he books a later flight. You can use whatever letters you want to represent whatever part of this statement. All right, now let's put this into symbols. So he is able to get someone to cover his shift and goes on the trip. Comma tells me that those are grouped together. Okay. Then we have or. He books a later flight and goes on the trip. So I just put this statement into symbolic form. So now what we can do is we can either make a truth table, but just make the column or the row that we need. So in other words, when we make our P, our Q, and in our R row, we just need to consult this specific case. So he is not able to get someone to cover his shift. That means that P is false in this case. because the way that I have P set up is that he is able to get someone to cover. He does not book a later flight. And that would be R stands for that he books a later flight. So here he doesn't. So R is false. And then he goes on the trip, which is what Q stands for. So Q is true. So we only need to make the row of the truth table where P is false, R is false, and Q is true. And then we can go from there. So we could make we could just create this one row and then find out the overall truth value. So P and Q would be false. R and Q would be false. Put an OR between those, and that is going to be false overall. The other option, instead of the truth table, is to just insert the values into, so here's a different way to do it, into the simple statement, and then work it out. So in this particular case, P is false, Q is true, R is false, Q is true. So whenever I see a P, I'm putting a false in there. Whenever I see an R, I'm putting a false in there. And whenever I see a Q, I'm putting a true in there. Okay, now, if I have a false and true, I know that with an and statement, that's going to end up false. Again, false and true is going to end up false. Now I have an OR between two falses, which is going to be false overall. So this statement is false overall in this specific case. And I've just shown two different ways to do it. One way is to just make the appropriate row of the truth table. Another way to do it is just to insert the true and falses into the symbolic statement and then use the rules of logic to work it out. This concludes example 9.